Here we go. We are starting off today by talking about Euler's number, and then we are going to solve exponential functions. So Euler's number, it is like pi and I. The number e is denoted by a letter. Okay, e is a number. It is Euler's number. It is the number 2.71 blah, 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 blah. It is an irrational number, meaning it does not repeat. If you wanted to actually know what the number is, you could use your calculator. Okay, right here you would have to hit second, and right here is the E button, right on that natural log button. We hit that button right there. Notice that it always gives you an exponent when you're trying to do E. So if I want to know what the number E is, what would my exponent be? 1, e to the first, oh yeah, 2.7182, blah, blah, blah. You don't need to memorize it. You just need to know that it's a number, and 2.71 is a good number to know. Okay? The number E is crazy. Okay, I don't have time to get anywhere near an explanation to it. Okay, this is how you actually find E, but that's not exciting. Okay, E is why photographs are the size that they are. E is why ocean waves do the thing that they do. E is why we are able to figure out how old dinosaurs are based off of their bones. Okay, we're able to understand how a seashell works or how a flower is grown. All of those things are based off the letter E. Okay, and the number that goes with it. It is a number that occurs in nature. It's pretty crazy. Okay, there's some good stuff out there. We just don't have a ton of time today to get into that. Okay, we are graphing f of x here, negative e to the x minus 3 minus 1. That is an exponential function. Okay, how do I know that? Because x is in my exponent. So it's going to look just like all the exponentials we graphed on Friday. Show me with your arm, what does a basic exponential graph look like? A basic exponential graph that you all just showed me looks like that. It takes off like a rocket ship, just like we learned on Friday. Show me with your fingers, where's the horizontal asymptote going to be on our exponential graph? Should be at -1. Whatever's added on there on the outside is going to be my horizontal asymptote. So I'm going to -1. Drawing a horizontal asymptote. It's an exponential graph. I'm going to make my anchor dot. Is my anchor dot going to be above or below my asymptote line? Below. Why? Because it's negative. Because that negative right there, I'm flipping my graph vertically. So my anchor dot would be 1 below, but it's not going to be right here. Point. Which direction am I going to move it? I am moving to the right 3 because of this -3 right there. So I'm to the right 3. My first dot is 1 below the line. As I move to the right, how many below the line is my next dot going to be? 2.71 because my base is E. My first one was 1 below. My next one is going to be 2.71 below. Okay, and then if I kept moving over, my next one would be E squared below that line. Oh, 7.389. 1, 2, 3, 4, 5, 6, 7.389. I'm not really concerned about that being the perfect graph, but just know that an exponential with E is going to look kind of like that. It doesn't look a whole lot different than what we did on Friday. Who cares that they changed the letter E instead of 2? We're still good. Domain, all real numbers. Range, y is less than -1 because my graph is below that -1 line. Questions? On the front side here, we are solving exponentials using what we talked about in Bell work. We're not using a calculator for any of these questions. Okay, they're all pretty straightforward. You'll be able to solve most of them. Okay, the key to our happiness today is rewriting both sides to be the same base. 2 to some power is equal to 2 to the 8th. Well, if they both have a base of 2, then x is equal to 8, and I'm done. If I can rewrite both sides to be the same base, then my exponents are going to be equal to each other. Okay, so for letter A, 3 to the 2n plus 1 is equal to 81. Over here, I have a base of 3. If I could rewrite both sides to be the same base, then we're going to win. Okay, 3 to 2n plus 1. Can I rewrite 81 as 3 to a power? Yeah. We always go down. When we're rewriting as a base, the numbers are always going to get smaller. I can't write 3 to the 81. That's cheating. But 81 is the same thing as 3 to what power? 3 to the 4th. You might not remember that, but you should. 3 to the 4th power is the same thing as 81. We rewrote both sides to be the same base. Now that we've done it, it's just a simple solve. Cancel out the 3's. 2n plus 1 is equal to 4. Minus 1, minus 1. 2n equals 3. Divide by 2, divide by 2. N equals 3/2. Make sense on A? Try letter B. Talk with each other. Try to figure out what you're going to rewrite both base to be. Go. We're rewriting. I've got 4 to the 2x and 8 to the x minus 1. We always are going to go with the smaller base. So 8 is bigger. So can I rewrite both sides to be a base of 4? No. That's the mistake students try to make, is they try to write 8. Well, no. 4 to no power gets me 8, so that doesn't work. So instead, I have to go even smaller. Okay, my base on both sides needs to be a 2. All right, so if I rewrote 4, I'd rewrite it as 2 squared times the original exponent of 2x. And 8 rewritten is 8 is 2 cubed times the original exponent. And the number one mistake we'll make today there is not putting it in parentheses. We've got to distribute that 3 to both things. When we get to our next test, that's what students miss every time. This cancels. 4x is equal to 3x minus 3. Minus 3x minus 3x. X is equal to negative 3. Questions on B. Let's go to number C here. I already started it. I might as well finish it. 16 to the negative v is equal to 1/4. What base can I rewrite both sides to be? 4? Yeah, we can do 4 or 2, right? If you can write it as 4, then you can write it as 2. Do the easier one. Whatever you know how to do, make sure you got it. Okay? So if we wrote both sides to be a base of 4, 4 to what power gets me 16? 2. So we would have 2 times that negative v. And 4 to what power is going to get me 1/4? Negative 1. Once we've got there, bases are the same. Negative 2v is equal to negative 1. Divide by negative 2. Divide by negative 2. V equals negative 1/2. Not just plain. Positive 1/2. Because I got 2 negative signs. Questions on C. Then let's get to the tricky one. Letter D. 3x all squared over 3 to the 5th equals 1/27. What base do you think I'm going to rewrite both sides to be? I'm going to rewrite both sides to be 3. Over here, it's easy. 3 to what power gets me 27? 3, but I need a negative because it's a fraction. So 3 to the negative 3 over here. On the other side, I need to take all of this and rewrite it as 3 to some power. Use your brain and talk with your neighbor. Think about what is the new exponent going to be that is going to simplify all that trash into just one single exponent. Talk with each other. Figure it out. Anybody got a good idea here? What's my new exponent going to be? It is 2x minus 5. Good stuff. Understand why. Okay, this kind of threw off us in first period. This is 3x times 3 to the x. That is what 3x squared means. So what am I going to do with the exponents if I am multiplying them together? Adding. Or in other words, I'm raising it to a power. It's just 2 times x. That's where the 2x comes from. Then I'm dividing by 3 to the 5th. Okay, you can think of it a couple of different ways. If I'm dividing, what do I do with the exponents? You subtract. Or you could say it's times 3 to the negative 5 because it's in the bottom. Well, then it's just put my exponents together. I've got x and another x is 2x and then minus 5. However you want to do it is great. Okay, Sophia was talking about multiplying 3 to the 5th to the other side. You could do that, and you would just have to do some different math. But no matter how you do it, you should be good as long as we rewrite the base to be 3 on both sides. Then it's easy. Cancel, cancel. 2x minus 5 is equal to negative 3. Add 5. X is 1. Try letter E with your neighbor. Go. All right, let's look at letter E. Show me with your fingers. What'd you get on E? What base did we use? 9. Could I have used 3? Sure. You could use 3. I'm going to use a base of 9 because I can easily rewrite 1/9 as 9 and 81 as 9. You could do 3 as well. Okay. When in doubt, 2, 3, and 5 are going to be the bases you use a lot. Okay, normally 2 and 3. But you could always do other ones. If you see other ones, use other ones as well. So, obviously 81 is 9 squared. What would I need to rewrite 9 to be the same thing as 1/9? -1. So it's 9 to the -1, and then don't forget to multiply inside of parentheses times all of those. The 9s are going to cancel, distribute, subtract 2, v is equal to 0. Questions on E. Let's look at letter G. What base do you think I'm going to try to rewrite both sides to be? E. So left side, we're good. Ooh, the right side. Take a second. Think about what would my new exponent be. If I wanted to rewrite that as just E one time with a base of E, what would the exponent be? Think about that. My exponent would be 2x minus 3. Again, same thing as the one we did up above it. EX squared is like e to the x times e to the x times e to the -3. That's what this is. Okay, so 1x, oh, that's 2x, and then minus 3. I'm just adding the exponents. Once I've gotten to this point, what can I do next? Cross out the e's. I get that. Now what do I do? Move the x squared because it's a quadratic. We need to set it all equal to 0. We get this guy. I factor x plus 3, x minus 1. X is equal to -3 and a positive 1. Good on G. When you multiply exponents, you're adding. When you divide exponents, you subtract. If you raise exponents to a power, you multiply. When in doubt, just think of like ones you know, like 2 squared times 2 squared. And think your way through that and what you would end up coming. All right, I don't love question H. It always kind of throws students off. Don't let H bother you. If we get done with H and you're like, that was really weird, fine. Let it be really weird and move on. Okay, so if we look at letter H, we have 2 to some power gets me 3. In the end, I want to know what 4 to the -x is equal to. Okay, so my job is to transform this guy into this guy, because if I do that, then I'll be able to transform the other side as well. So, what is a step that I could do here that would make 2 to the x closer to 4 to the -x? Yeah, that's fine. Let's just do that. 2 to the -2x, right? Because 2 to the -2x is the same thing as 4 with a negative exponent, right? Or you could just, however you want to do that. All right, so whatever I do to one side, I need to do to the other. So what did I do to the left side? I raised it to the -2 power. So what do I need to do to the right side? I need to raise it to the -2 power. This is the same thing as this. So all I need to do is figure out what 3 to the -2 is going to be. What's the square, or what's the negative going to do? 1 over, and then 3 squared is 9. My answer is 1/9. It's a little bit strange. It's just a matter of saying, how do I transform what they gave me into what they want? Okay, and in this case, I raised it to the second power and I made it negative. So you said if it makes no sense, just ignore it? Yeah, just work your way through it. It's a little bit strange. Don't let it be that strange. It was about transforming what we had. Questions? Lesson 1.